everybody, how are we doing? Watch the light come on. Here it goes. There's the light. Is anyone in the chat? How are we doing? We could do some chapter 6. We do some campus content. Whatever you think. Gonna start charging my Pokemon clicker because it stopped working. Had to charge the pen. We're logged into Canvas. Ella, good to see you there. What questions do you have? You get to pick what we work on. So pick what we work on. I cut my finger. It's all right. It's such a small cut. I cut it with my knife skills because I got really good knife skills. That's a joke. But I was cutting an apple and I was like, chomp, chomp, chomp. Disk drives, you bet. Logged into MyPearson. And I was like, slip. And I went, boop, against my finger. And I was like, I'm gonna cut the finger. It's fine. Like it's a very surfacey cut, but it broke the skin. And I was like, it's sad. Did it on Friday too, so it's healing up. Ugh. Don't let Brian use knives. It's not permitted to use knives. My wife told me. She said, you were using the knives? I told you not to use the knives. Only I can. We're getting the MyPearson loaded up right here. MyPearson. A good one right here. Hard drives about correlation. What are the conditions for correlation? Ella, what are the conditions? There are 3 conditions for correlation. We use 2 letters for the first one here. I'm loading up the assignment while we talk about this. Disk drives getting larger. Chapter 6. Chapter 6. Quiz question. Do we know the conditions? What are the conditions? Anyone know them? Throw out points. Let me throw out Ella points for just being here. These get points for being here. What are the conditions for doing correlation? Writing in the thing. 423. Chat 201. Chapter 6. MyPearson Quiz. Kind of. QQ straight enough, no outliers are the conditions. QQ straight enough, no outliers. I don't think it'll come up in this one so much, but those are the conditions. QQ straight enough, no outliers mean 2 quantitative variables, straight enough relationship, and we do not want to see extreme outliers, so we call it QQ straight enough, no outliers. Go find this question. QQ and Ella, thank you for that answer right there. 50 points for the answer. Hard drives have been getting larger. Disk drives have been getting larger right here. And so this is the question. The capacity is now in the terabytes. Terabytes 1,000 gigabytes, which is 1,000 megabytes, which is 1,000 kilobytes, which is like how many bits? I don't know. 8-bit? I don't know. 12 bits? Something like that. It goes, yeah, big disk drives. And then we got petabyte, zettabytes, yottabytes. It's pretty crazy after that. You don't got to know these huge things in the measuring system. So here's the data right here. If you notice, we probably want to predict how much a hard drive costs. When you are doing variables, let me make sure, I'm going to take a screenshot here. When you are doing variables and you are doing bivariate relationships, one of those variables will be the what? Good morning, Daniel. Good to see you here. When you're doing bivariate relationships, one of the variables will be the what, and the other variable will be the what. So when you're doing bivariate relationships, one of the variables will be the what, and one of the variables will be the what. When you're doing bivariate relationships, usually we assign one variable to be the this variable and one variable to be the this variable. Think of words we use for this. These are the key things to learn from this class, kind of like the pivotal understanding, the base root level knowledge. What do we call one of the variables and what do we call the other variable? Lots of words to use for it. So there's lots of good answers here. There's some great answers. But how do we talk about the variables? So those are the variable types. All the good points right there. So those are the variable types. So we have quantitative variables in this instance. You get some points for that right there. When we're doing like a relationship between 2 variables, we want one to be the y. And we say, why do hard drives cost so much? The thing about why it's the y, you care about it. You want to understand it, the variable of interest. And then we have maybe capacity explains it. So capacity is the explanatory variable. In mathematics, it's often called the independent variable because it's part of the equation like y equals mx plus b, where you have y equals mx plus b. So the value of y depends on x. I don't prefer to call it the independent and y the dependent. I prefer to call x the explanatory variable and y the response. Because we're going to talk about it. You're going to respond to what y is, respond to the price, and we're going to use capacity to explain it. Now what we want to do is we want to go into jump. Jump's going to make our lives easier. I'm going to make sure I don't have any. I got a bunch of data. See what data I got open here. Okay, I'm going to open a new data sheet. I'm going to show you how to do this. Okay, so we're going to take jump and go to File, New Data Table, which you'll get one of these sheets right here. Don't click inside the sheet when you get the sheet. File, New Data Table. If you're on a Mac, it should be up here at the top of the screen to go File, New Data Table with the jump window active. Now don't click inside of here once again. A lot of people do that very quickly. We're going to go over here, and from here we're going to click the data table and we're going to copy to clipboard. So copy to clipboard. Hit Control C or Command C to copy the data. There's the data we see. So rather than entering it in step by step by step, we're going to go over to jump and we're going to go to Edit, Paste with column names. Now I can't state this enough that you need to go to Edit, Paste with column names. And there's something very important when you do this, and that was Edit, Paste with column names. Make sure to click that one for this data. If you notice here, the column names are at the top. If you did this incorrectly, you will get categorical data because it'll put the column names in the first row, and it thinks that you have titles or characters, and so this will be wrong, and you cannot analyze that data properly. If you get a mosaic plot, you have done this wrong. For example, the data here is wrong. So if you were to do this right here and run the data, it's going to look like this, and this is incorrect. Once again, make sure to paste with column names when column names exist. If you see the column names have appeared at the top of the screen and you have quantitative columns, this data has been pasted correctly. So now that we have the data properly in jump, we can go here to Analyze, Fit Y by X. So think about what Fit Y by X is. It's looking at a what variate relationship. Y by X. It's looking at a what variate relationship. Points in the chat. So when you do y by x, you're analyzing a what relationship versus distributions, which is just univariate. Bivariate, Ella, great job right there. We're going to throw you 100 points. And what's really cool is jump shows you the combinations of what you'll get. If you do two quantitative variables, like a quantitative x and a quantitative y, you get a scatter plot. If you do a categorical y and a quantitative x, you get logistic regression. We won't do that in our class. If you do a categorical x and a quantitative y, you get side-by-side box plots. And two categorical variables gives you mosaic plots with contingency tables, hence contingency. So you can kind of see the combos of what you get. And we're going to put the price is what we want to understand, the y variable, and the x right there. And you see it says right here bivariate. I don't know why it calls it bivariate. It should say scatter plot because all of these are technically bivariate. Let's go ahead and run this now and click OK, and there's the scatter plot. Now you can also kind of trace this on your own, but the answer is pretty clear. It's going to be this graphic right here. There is this point over here that is very far away, and they're going to kind of hone in on that in this question. The key learning objectives we like to talk about: a scatter plot is a bivariate visualization of two quantitative variables. Have that in your notes and know it. Like when I say these things, have a note card right here and be like, a scatter plot is a bivariate visualization of two quantitative variables. However you want to make that a note, and we analyze it with the strength, direction, form, and unusual features. What is the direction of this scatter plot? So what is the direction of this scatter plot? The four characteristics of a bivariate relationship that we analyze are strength, direction, form, unusual features. What is the direction of this? There's only really two directions, and then things that kind of don't do either. What is the direction of this? It's a whole review of the chapter now, basically. Increasing, positive. So we'd say this is a positive relationship. Now, form is either linear or not linear. And the way to see the form of it is to try to add a line. And if the line goes through the data well, as in, we don't need to make the line bend to make it go through. And if look at this, a bendy line would do better. Like if we did that, it's more of an exponential. So the line is not really an amazing fit to this, so it has a non-linear form. Form just means the form they follow. Like how would you describe this? Is it a line or not a line? Now there's a lot of not line things. There's like sigmoidal or sinusoidal relationships, but this one right here I would say is not well described by a line. Unusual features. This is kind of an unusual feature up here, that outlier. Strength is moderately strong because the points are decently close around the line, and they'd be even closer around the actual form, which is the nonlinear form. Strength is the measure of vertical scatter around the form. So that's a very strong linear. And then if you were to zoom in over here and draw this, this is a very strong nonlinear if you were to draw this, because all these points are tight around the form. So the bottom one is a nonlinear form, and it is strong. And this is a linear strong right here, and they are both positive, and they don't have outliers. Look at that, strength, direction, form, and we didn't really mention unusual features for those little sketches, but you should understand what strength, direction, form, and unusual features are, because a lot of these questions will go over them. Really good review. Make sure to know the concepts as we go through these. What would you say about the direction? Well, we said that. What can you say about the form? We said that too. It is curved, non-linear. What would you say about the strength? Now remember, strength is how tight it is. So weak is going to look more scattered. Weaker relationships are going to look very scattered around the form. Although this is not perfect, really perfect, it is going towards more of a strong relationship right there. So this is relatively strong, not super duper strong. Does the scatter plot have outliers? Yes, it does. That one point we see over here is the real outlier, because you generally have this, and then you could have this point over here. We can even cheat and jump by going in and going to fit line. And you see it's a univariate outlier, but it really, once again, this is, you don't have to do this, but if you were to fit a polynomial form, you could see the polynomial fits better. So I think they are going for this one being an outlier. There's a lot of weirdness, but the bend is something, the nonlinear is there. So yes, the 32 terabyte is going to be what priced? Let's go look at the model again. I'm going to remove the polynomial form. So is the 32 terabyte overpriced or underpriced for its prediction? So look at the 32 terabyte up here. Is it overpriced for its prediction? The line is the predictions, or underpriced? Is the 32 terabyte hard drive, which is right here, over the predicted price or under the predicted price? So is it overpriced or underpriced? Is the 32 terabyte overpriced or underpriced? It's overpriced. Yep. Great job, Ella. Amazing answers today. And so yes, the 32 terabyte is overpriced, and that's the one I think they're going for right there. Oh no, not this one, is it? No. Oh, it follows the pattern. Really? Really? It's close-ish. Okay, we got one wrong. That means we give 100 points. So if you're watching along, you can do an outlier analysis on this. You know what I want to, let me see here. We're gonna do a quick follow-up on this. I'm going to do a follow-up and see if I can prove MyPearson wrong. So let's see if Brian can prove MyPearson wrong. Oh man. Okay, here we go. Size, give another question here while we do this, and I'm gonna try to see if I can show if they're right or wrong. Who was right? I'm going upper level statistics on this. We are gonna see with upper level statistics if Brian is right or MyPearson is right. We will find this out. Oh, did I just, there we go. Oh, it's 0.5. You can't have a 0 terabyte hard drive. Any more questions in the chat, or is this the only one we're gonna do? People say we only did one question. I want to know. Could have saved. Well, I could have loaded in a CSV. 423.99 581 1079 44. Okay. M save into LM price. Oh, yeah, we're gonna explain price or understand price. Oh, I didn't capitalize it. There it is right there. Influence plot. The answer is that point on. Yes! MyPearson, come on. My years of analyzing data told me that that point is very unusual. And it's because of its high influence, MyPearson, that it's not got as big of an outlier as it should because of its ridiculous influence on the model due to its large leverage, its Cook's distance. World Happiness Report, you got it. So technically, MyPearson is wrong on that. It is overpriced, and it's a highly influential point in the model, marked by the size of the circle here, which I believe is measured by Cook's distance. They come up with stats names. It's called influence. But it is the most influential point in that model. If you were to remove that point from the model would drastically change. Like, think about the size of these circles as their influence. All other points in the model have basically no influence. The one thing creating the model is that point. That point has ridiculous undue influence. Should be Cook's distance. So, yeah, it's this point right here, which has the only... Everything else has like very small. Here, I'm gonna show one more thing. Then we'll do that. World Happiness options. SciPen 10. There you go. It has a. Oh, you can't see because I'm zoomed in. It has an influence of 21.94. Every other point has an influence in the decimals. So that point is ridiculously influential, and that's why its residual is not as large as it should be. We don't go over influence in 201, but we do in 320. And my knowledge of statistics said to me, well, wait a minute. So please make sure to answer it the way MyPearson wants you to answer it. But that's why statisticians can disagree. And I'm going to give a number to back it. Like we always say, you know, give numeric backing. So I'm going to say the influence of this point is relatively 150 times larger than all other points in the model, causing us to underestimate its residual. The model is being pulled towards this point because outliers can do anything. We know that. So let's go do the next question right here. I'll say MyPearson, I got that right. The answer is more in depth than MyPearson wanted to give. The residual for the 32 terabyte is being underestimated due to its high influence measured by Cook's distance. The model we should consider this point and its high leverage to be possibly an outlier because the model is pulling towards it, measured also, or with our understanding of deleted studentized residuals, which that's another topic. These are things that are often hard to communicate. What's a deleted studentized residual? You got three concepts in one there. Okay, the World Happiness Report. Let's go do that question. I said MyPearson, I got that right. I don't like getting questions wrong. I'm like, where's my stat knowledge gap? It isn't that big of a residual, but it's literally due to the influence of the point and its deleted studentized residual. I like those a lot. These are great questions. These are the best. That's a quick one right there. Kentucky Derby, nonlinear relationship. Good questions there. Good questions on scatter plots. Where is it? The World Happiness Report. That's a good one too. World Happiness Report, the last question, let's do it. Okay, here we go. So this one's kind of a weird one. I'm going to tell you the answers to it pretty much because the concepts they're talking about are something we barely mention and it really doesn't go on the test much. No, this is on the test. Okay, good. Because it's just variables. What you got here, and this is on the test, is what's called a correlation matrix. Now, the things that are usually not of interest in a correlation matrix are what we call the diagonal right here, because that's where you pair one-to-one the same variable. So the correlation between happiness and happiness is 1 because it's the same variable. So we don't usually care about that. It's a novel idea that X and Y, if they're the same variable, have a one-to-one correlation. That, as Rock would say. It doesn't matter. Now, this other side, sometimes people leave it blank because it's a mirror image of the other side, so they don't want to just kind of give you too much information. The only thing that really matters here are these three correlations, which are the three correlations between log GPA per capita and happiness, health, life expectancy, and happiness, log GPA per capita and life expectancy. And you pair them in here by simply drawing across them and pairing down. So if we were to ask you the strongest correlation, which is a test question we usually give, if we said, what is the strongest correlation, you'd go to the one that is closest to 1, and then you would look at the two variables that intersect on it. So it'd be log GPA per capita and healthy life expectancy. Now, also the weakest relationship in this is the one that's closest to 0. So if there was a negative in front of this, it would still be the weakest. Weakest is closest to 0. Strongest is closest to positive or negative 1. So the stronger a relationship is, the closer it is to negative 1 or positive 1. This only indicates direction. The weaker it is, the closer it is to 0. And it doesn't matter if it's positive or negative. Rock knows all the answers. Because weak is closer to 0 and strong is closer to negative or positive 1. The direction is only indicated by the sign, and the sign is not strength. It's just, does it go up, points going up around it, or points going down around it? That is the strength, that is the direction, up or down. So let's look at the questions they asked. That is some of the important stuff for the test. Always hone in on these sections right here if you're watching these, because I'm basically showing you what the test is going to look like by saying find the strongest correlation, find the weakest correlation, and then know how to find those. Like weakest negative would be a negative number closest to 0. Strongest positive would be a positive number closest to positive 1. Strongest positive has 2 qualities, right? The direction and strength. So is log GPA per capita more strongly associated with happiness? So what's it most strongly associated with? Log GPA per capita, if you look right here, has a stronger association with healthy life expectancy. And all we're doing is finding with log GPA per capita. You notice right here, here's its happiness correlation, and here's its healthy life expectancy. So the answer is the correlation with log GPA and healthy life expectancy is higher, so log GPA is more strongly associated. Does this report provide evidence? Okay, so that says evidence, it doesn't say proof. Oh wait, that improved healthcare would result in greater happiness. Okay, the word will there, they're kind of implying that this will happen. They didn't say will, but would. That implies like if you change this, this will happen. It sounds like a cause and effect. They didn't say the bad cause word that we don't like in our class, but we don't like cause, prove, will, know. So imagine this. There's a correlation between height and weight. So if Brian gains weight, does that mean he'll get taller? So what do you think in the chat? There is a correlation between height and weight. If Brian gains weight, he will get taller. There's a correlation between height and weight. There's a positive, somewhat linear correlation between height and weight. Weight down here is the X, height is the Y. If Brian gains weight, he will get taller. Is that what that means? Or if people gain weight, we would expect them to get taller. Know what that means? No. Economics, you got it. So correlation is not causation. It's true that people who weigh more are generally taller, but gaining weight, at least at this point in my life, is not going to have me get taller. You could talk about what if you're 10 or something like that. You probably need to gain weight for your health, your body to grow. Yeah, maybe then. But at this point, me gaining 20 pounds is not going to get me in the NBA. So with this right here, the way they phrase it makes it sound like correlation is causation. Like if we do this, this will increase this or would increase this. No, because correlation does not prove, and you can't have a high enough value. There's no high enough. You can have a 1-to-1 correlation and that doesn't prove causation. So we should get everything right. Really? It's the top one, isn't it? Is the top one. How do I mess this up? They want to see the scatter plots. If they are linear, which one? Oh, no. They pulled a cheat word on me. 100 points, MyPearson. They pulled a cheat word. This is a huge, and I rewind the tape because I'm pretty sure I said strongly correlated. They said strongly associated. Correlation is only one type of association. If there is a nonlinear form to it, there could be a stronger association between the other variables. So especially in our class, we mentioned that correlation can be 0. So the answer would be, if the GPA just wants to show it, yeah, it's gonna be this one then. Yep. So they pulled a cheat right there on me, which is all right. You trying to, okay, you say, oh, Brian, you know stats. Well, we're gonna make sure you know it. Because here is a classic test question. So please check this out. Once again, why are you learning this? For the test and to know it for life. If correlation is 0, there is no association between X and Y. True or false? Someone in the chat help out right here. Take a shot at this. What do you think? If the correlation is 0, there is no association between X and Y. True or false? You get points for taking a try at it. You're practicing for the test. I've seen this on the test. You're watching this in the future, put it on a note card, know the answer to this, and then know why. So if correlation is 0, there is no association between X and Y. This is what they were getting at with their question. False, Savannah, 100 points. That is false. Because correlation only measures linear associations. So if you have a relationship, something like this right here, you will get a correlation of 0, but there is a sinusoidal, like sine wave form to the relationship, like a sales, maybe your sales dip in the summer and they get high in the year. Maybe this is like Christmas tree sales. You sell a lot towards the end of the year, and then you've got a like going out of business Christmas tree sale, but then you make no sales in the middle of the year. There's an association to when you sell Christmas trees, but they're not correlated to time of the year. It's associated. There's no linear correlation. So correlation is only the idea of a linear association. So correlation can be 0 for non-linear. So this would have a correlation of basically 0, and they are still associated. So that's what they're getting at, because they asked me what is the strongest association in the data. The strongest correlation is easy to find because it's just right there. That's the strongest correlation. Now, it could be that there's a nonlinear form, as they're getting at. Without scatterplots, it is uncertain that the underlying relationships are linear. If they are linear, then the log GPA and the healthy life would be the highest. Good trick question. I got to give props. Okay. Let's do this question here. Savannah has, if we assume the conditions are met, is that the question right there? If we assume the conditions are met, I think so. Thank you, Savannah, and everyone here. And good job, Savannah, on this practice. You know the trick questions. Don't get tricked on the test. Put it on a note card, and when you get to the test, be like, Brian said this could be on the test. Brian said this could be on the test. And you're like, man, I just studied half the test. And then know the reason why. I can't state enough. Know the reason why. Don't just memorize like correlation can be 0 and there still be an association. Well, it's because when you have correlation of 0, there could be a nonlinear relationship association. Same word. Okay, we got here, if we assume the conditions, let me grab the second one. What is the correlation? Oh, that's what it is? Is that the question? Thank you, Savannah. I'm marking all these down, and I'm gonna go, is that the question, like what is the correlation? I like the scatterplot ones a lot. If we assume the conditions, I'm doing the, if we assume the conditions. Oh, what is the correlation for what, Savannah? If we assume that the conditions, I think this is it. Okay. Explain that last one. I'll delete. What is the correlation? Okay. Here we go. Question time. Let's do it. If we assume the conditions are met, which are QQ straight enough, no outliers. So we're analyzing the relationship between two quantitative variables. You have to do that to do correlation. Sustainment ones. Okay. Yeah, we'll find that here in a moment. And so you have to have two quantitative variables to do correlation. You have to have a straight enough relationship because correlation only measures linear relationships. So if you're not doing that, you really shouldn't be doing correlation. And then you need to have no outliers because outliers, as we like to say, when it comes to outliers, where's my thing? Anything is possible. You see outliers can do this correlation? The answer is true. A correlation of 0.02 indicates a strong positive association. Strong associations are closer to what or what? Strong associations are closer to what or what? This is once again a note you should have. Strong correlations are closer to what values? This is one of them. Nice. Strong correlations are closer to what or what value? One or, in this instance, one, because positive. One or what else, Ella? And good answers. Strong correlations are close to one or what else? Negative one. And that's just the direction then. So right there. Great job, Maggie. And good to see you there. A correlation, there we go, the correlation, no. This is a correlation of 0.02 indicates there may be no linear association between the two variables. True. Next is standardizing the variables will make the correlation 0. Standardizing means turning them into, think one letter, what scores? Standardizing means turning them into what scores? Standardizing turns them into what scores? Standardizing turns them into what scores? Standardizing turns them into what scores? Standardizing means turning them into what scores? z-scores, and you're already doing this in the equation. So the equation in the background, one way to do the equation, great job Elizabeth, already does this. So will this impact the correlation? Here's the answer. Some of the equations, some ways of calculating this, which will derive the same answer. You can see other ways behind me here. Some ways do this for you. Correlation is unitless like z-scores. It measures the strength, direction, form, and is impacted by unusual features for two quantitative variables. And so this won't change it. The value of R, which is sample correlation, is going to be found after you standardize the variables. So the answer to this is you're already doing it. So will it make the correlation 0? That is false. Standardizing the variables, no, it won't do anything to it. Changing the units is good right here. Changing the units of both or one of the variables, or in this case, removing the units by standardizing because it's unitless, will not affect the value of correlation between the two variables. This is something that is true. I can't state that enough. Correlation's unitless, z-scores are unitless. Changing it to z-scores is not going to change a thing. Adding an outlier can dramatically, what do we say about outliers? Can outliers make a weak correlation strong? Can outliers make a strong correlation weak? Can outliers make a positive correlation negative?
Anything is possible!
Can outliers do that? You see this on the test. Outliers can do this to correlation. Outliers can make a weak correlation strong. Everything is true when it comes to outliers and correlation. They can do anything. Really, this is a very good question. Can do anything. Anything is possible. This was a great question. Know these concepts. Understand that outliers can do anything. That's why we say QQ straight enough. No outliers. We don't like those outliers because they can do anything. And then we're basically doing a plot based on outliers. If you want to see, I went more in depth on this earlier on a question on MyPearson that I got mad at. And then MyPearson got mad at me back. Don't get mad at MyPearson. You want to be friends with MyPearson. So that's, yeah. Okay. So with this right here, let's do the which of these scatter plots. Some of my favorite questions. What is correlation? There we go. There it is. Measures the strength and direction of linear relationships. Strength direction is impacted by forms or impacted by unusual features. So strength, direction, form of, because form's linear. That is correlation. Which of these scatter plots? I love these questions. So which of these scatter plots right here is a really good way to understand what's going on with the 4 metrics by which we measure correlation or describe it. So what are the 4 ways we describe correlation? Who can tell me the 4 ways we describe correlation? Try to put it in the chat right here. I need the 4 ways to describe it. The 4 ways to describe correlation. Think of the 4 ways to describe it. Who knows the 4 ways to describe it? I need 4 ways. Think of the 4 ways to describe it. This is the good reviews you need. Not a good guess, Savannah. Fat pencil, good guess. I've got a hint up there at the top. I put the 4 ways, the first letter of each. See if that jogs your memory and be like, okay, we do shape, center, spread for histograms. Maggie, good guess right there. Shape, center, spread are for histograms. So a histogram is measured or analyzed by its shape, like unimodal symmetric, normal, then center and spread. But this won't be in good guess, Maggie. So this won't be, it'll be, think about this. We've been talking about it a little bit. The last question kind of did that. What is correlation? See, I'll give it another moment here. Don't worry about being wrong. We throw more points for all these answers. What are the 4 characteristics by which we talk about the relationship between 2 quantitative variables in a scatter plot? I'll start writing it out a little bit more to help out. Yeah. What we got? Let me finish this off. Strength, strength, direction. Write this down if you don't have it. Form, unusual features. And I don't know is a great answer right there. We're throwing more points. 100 points for everyone. Just trying out. Don't worry about being wrong. I don't know is a great answer. It shows me you're just following along. Strength, direction, form, unusual features. Strength and positive and negative is a part of direction. And not really formation, 100 points again, but the form of it, Like, how does it look? Does it look like a line? Does it not look like a line? Formation kind of works. How is it formed? How is it formation? Yeah, I can go with that. I can go with that. We call it form though, but kind of works. So when we look at the strength of it, let's first analyze strength right here. And to analyze the strength, we need to look at how tight it is. I guess I'll do this right here. Which of these looks to be the strongest of it? Which of these looks to be the strongest? The tightness of the points is the strength. Give me ones that look to be the strongest. Let's write strong right here. Which of these look to be the strongest? Strongest. These looks to be the strongest. 1 and 4. So this is strong. This is strong. This is moderate. This is moderate. We say moderate, strong, or stuff like that. 1 and 4, I'd say, are the strongest. 1 is probably the strongest. 1 does look to be the strongest. So we'll say even here, very strong. Now we got to look at the direction. So here's the direction of this one. Here's the direction of this one, direction of this one, direction of this one. So if you notice, we only have one negative. So this is negative, positive, positive, negative. Now we need to look at the form of it. And the form is either it follows a line or it doesn't. So you try to go through the middle of the data. And we have here linear, 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 and not linear. Does that make sense? You see how I was able to analyze the strength, direction, form, and there's not really any big outliers in any of these. An outlier would be something that breaks the trend. Like if there was a data point all the way up there, that'd be an outlier for that data set. So now that we have the answers with strength, direction, form, no unusual features, they didn't put any outliers in these graphics, we can start to analyze the relationships over here. So which of these show no association? None of them do. They all have some sort of association. Which of the scatter plots is a negative? It's only the one that goes down, so it's only graphic 1. Which of the scatter plots show a linear? It'd be 1, 2, and 4, because those are linear. Which of the scatter plots shows a weak or moderately strong? Okay, so here's where it gets scary. Let's say very strong. We said very strong is 1 and 4. So 1 and 4 is very strong. That's those are very strongs, because yeah, 1 and 4. It doesn't have just 1. Look at that. It doesn't have just 1. So we were like 1 is very strong. We know that. And then 4 was our next one. And these were just my moderate strongs, not very strongs. And when we saw moderate strong, I'm thinking 2 and 3. That's good right there, because these both have decently tight, and they're saying weak kind of through moderate strong. A little tricky, but we said, and we basically said none of them have no association. And look, so 2 and 3 are moderate strong, and these are very strong. So we've kind of labeled them all. That should do it. Yeah, I got 100. Very good question. There's many versions of this. So if you get good at this question, you can kind of see, I'm trying to get a different version that looks very, that one, but is already filled out. Come on, give me a different version not filled out. This is going to just keep doing the original version of it. Really? That 4 is super duper strong. This is a good question to make sure you understand it. There we go. Here we go. Okay. Which graphic up top is non-linear? Which graphic up top is non-linear? Which graphic up top is non-linear? 1, 2, 3, or 4? Which graphic up top is non-linear? 1, 2, 3, or 4? 4. 4 is non-linear. Correct. Great job, Emma, right there, and Maggie. We'll throw you some points. 4 is non-linear because if you try to put a line through it, a line, although it can go through the data, is not the proper form. Now, which of these graphics has no association? 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 Which of the graphics on the screen has no association? What I'm drawing here is no association. That's what no association looks like. That is just random. 100 points, Maggie. It's not 3. 3 has but 100 points, remember, wrong answers. We just get them out of our system. 3 is a moderately strong, positive linear association. 3 is a moderate or moderately strong linear positive association. If you were to see no association at all, it should look very random. And this is the no association graphic right here that I'm circling. That is what no association will look like. Other ones might have a non-linear association. So this one right here is a non-linear association. So we could find one of the versions of the question that does the no association. But does that make sense? They all have some sort of association, but some of them are non-linear. Exactly. And they're not doing a no association. I'm trying to generate one. That's a very weak. This goes down, but that is weak. So I'm just trying to get them to show me a random one. I thought they did it sometimes. They show like a random, and I can show you what the random one looks like. Those are, yeah, they're not giving me, might be, let me go to the other, do like a few more of these. I like these a lot. I think they're really good for practice. There are more versions of them. Yeah. Which graphic has no association? 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 Throw some points out here. 2. 2 looks completely random. One trick you can do is draw around these, and you can see right here, this goes down and this goes up, and this still makes a 1 of sorts. So you can kind of guess the correlation, or remember, it only measures linear. So this might be, we're just taking guesses. We're just taking guesses. So Brian thinks the what of 1 and 3 is about the same. Brian thinks the what of 1 and 3 are about the same. Finish the sentence. Brian thinks the what of 1 and 3 is about the same. Brian thinks the what of 1 and 3 is about the same. Brian thinks the what of 1 and 3 is about the same. And I made a mistake. No, it's up there. Good. Brian thinks the what of 1 and 3 is about the same. That's a 9 down there, 0.9. Brian thinks the what of 1 and 3 is about the same. Strength. Great job, Elizabeth. That is correct, 100 points. The strength, they just differ in their direction. They have the same, does that make sense what strength is? It's the vertical scatter around the form. So these have the same strength as far as I can tell. This one's weaker because look, it's more spread out. And this one is the most spread out. And if you were to put a line through it, it'd be a flat line, meaning there's really no linear relationship. So this has a correlation of 0, no linear strength. Also, it doesn't have any sort of other association like a nonlinear one, like a exponential or a sine wave going through it. It's your random relationship where this is a moderate, positive, linear relationship. Why is it linear? Because if we put a line through it, the line goes through the data. If it's nonlinear, you'd see something like this with your data points. And when you put a line through it, the line would have to bend to properly go through it, and that's not a line. So hopefully, I really like this question going over strength, direction, form, unusual features. If we go through and practice these, we can see that its graphic 2 has no association. Which of them show a negative? Just look if it goes down. That's graphic 1. Which of these is linear? 1, 3, and 4. This usually gets healed because they don't think 4 is linear, but if you put a line through it, the line goes through the middle of it. Which of these show a moderately strong? It's just 4 this time. Which of these show a very strong? It's 1 and 3, and we should get them all correct. Once again, really love these questions. You should understand strength, direction, form, unusual features, and this goes over the 4 key characteristics. Probably one of the best ones to understand and go over those concepts is this question right here, these series that do these questions. So I don't have a check mark for this one, so none of them show no association. Which of these is negative? It's graphic 1. Which question are we doing next? Show a linear, it's 1, 2, and 4. Good. Which of these show a moderately strong? It's 2 and 3. Very strong, 1 and 4. Should get it right. There we go. I want that check mark. So drop another question in the chat. Those just a very, oh, here's another one. So which of these scatter plots, here I'll do the here are several scatter plots, but drop another question in the chat because we're out of questions. Here are several scatter plots. We're out of questions. What? Is that 46 minutes? I can barely read the screen over there. Explain the mistake in the following statement. Oh, shows that there was almost no. Oh, because that only. Oh, that's wow. What are your thoughts on that, Savannah? While I'm doing this question right here, I got a lot of thoughts on that. Yeah, I'll do this one right here, and then I'll grab this next one. It's the other economics one. What does correlation measure? And then why would we say that that's just wrong? There's so many reasons that that's wrong. So we'll go to that one next here. So the way to do this one is to look for the one with no association first or no linear, hint for Savannah's question too. All right, let's do that next. Yeah. So B has basically no association right here. And some people say that's negative. It's so weak you can't really tell. It's basically 0. For all intents and purposes, that is 0. This is the strongest positive because it follows the line the most. So we're going to go down here, find the strongest positive, which is 0.951. This is the strongest negative. So we go to the strongest negative, which is negative 9.23. Not that. And then this is still has some linear strength. It'd be bad to use correlation here because it's not straight enough, but you will get a value of correlation. So, and it does have some linear relationship, but it's better measured by some sort of polynomial relationship. Don't get into that until 1, but there are ways to measure that. So the next one, assuming, let me grab this assuming thing right here. The relationship is linear. Okay. And explain the mistake. Okay, explain the mistake. Might be able, we can probably do a lot of these. The Katrina one's good too. These are quick if you know the answers. In economics, is this? Oh, it's this one right here. It's this one. An economics instructor. Okay. Taking the note on it. How I got which ones? Those answers there a second ago. I can go back to it here in a second. Those answers I just did. I can go back and talk more about that. But yeah, tell me. Yeah, thank you for that right there. I'll go back to those again if you want, and we will talk through them a little bit more. But please, please, please be like, how'd you do that? Why would we think this? Really good questions. Thank you for saying that right there, Elizabeth. Yeah, we'll go back and do it right after this. Okay. So with this one right here, an economics instructor assigns a class to figure out GDP. Each student analyzes different factors such as life expectancy, literacy rate, and all those things for a few countries. Apparently, some of the classmates do not understand statistics very well because several of their conclusions are incorrect. Okay. My very low correlation. Okay. When is correlation low? When it's closer to what value? Correlation is low when it's closer to what value? Correlation is low when it's closer to what value? Correlation is low. Careful. Elizabeth, 100 points right there. And Savannah getting the points too. Correlation is considered low when it's close to 0. So this is the low right here. I mean, you gotta be careful because they might be meaning like low, like a small number, like towards the negative side. So we prefer to say that this is weak correlation right here. So low is maybe not the best word to use. We'd call this weak. And the further out you go, the stronger it gets. Does that make sense? So strong is how much it forms around the line, how tight it is. And the slope of the line doesn't matter. This is an incalculable one due to lack of variation in the y variable. But the stronger it is, the tighter it is. So that's very important right there. The stronger it is, the tighter it is. So we'd say, well, you really have a negative, moderately strong correlation. Also, correlation only measures what relationships? Think of a 6-letter word starts with an L, or you can say the 4-letter word that we're talking about this right here. Correlation only measures what relationships? Which this answer is probably going to say. Correlation only measures what relationships? Which every answer states it. And then we basically have what we said before. Well, so the form that it analyzes is linear. Good answer is Elizabeth right there. It only measures linear forms strength. So assuming you have a linear relationship right here, your negative 0.772 shows a strong negative. I'd say moderately strong. It's definitely not weak because it's closer to -1. So I'd say it's moderately strong negative. Explain the mistake in the following. The correlation of 0.44 between GPA and continent. What is the first condition of correlation? What is the very first thing you must have before you start talking about correlation? Like, is gender and height correlated? Well, that's not really how we do it. It's associated. Is cheeseburgers you eat when you order from a restaurant correlated with restaurant you eat at? Like if I go to Crystal's, is that there a correlation between the cheeseburgers I order and the restaurant I go to? Might be an association. I might get more cheeseburgers if I go to Crystal's. There'd be an association. What is the first condition you must meet before you start talking about the idea of correlation? Which the answer tells you. The first thing you must have before you start talking about the idea of correlation, or it's not a correlation, it's some sort of association or something else. The first condition is what? You don't like to say 2 letters in the chat, and I know you'll know the first condition. What is the first condition you must meet? Once again, don't worry about so much about their answers. We'll find it by knowing the answer. Because they're talking about GDP, which is quantitative, and continent, which is categorical. The first condition you must have, correlation is only an idea between 2 whats. Not strength. Good answer, Elizabeth, right there. So those are the 4 ways of describing it. Strength, direction, form, unusual features are the 4 ways we describe it. But what you must have to do correlation is QQ straight enough, no outliers. And so Elizabeth's on the right track right there with variables. And we'll throw you some more points. Keep answering questions. You're getting those points left and right because correlation is a continent is categorical. So you must have 2 quantitative variables, an X and a Y relationship. Great job, Emma, right there. So it's only between 2 quantitative variables. So you can't do this right here because continent is categorical. So correlation is only the idea of the strength direction of a linear relationship between measuring the strength and direction of 2 quantitative variables that have a linear relationship, and that's when we use correlation, which is the kind of what is correlation idea went behind that. Now to do this question right here, the first thing to identify in this question is what is strength? Stronger relationships are what are around a line. A stronger relationship, you can look at this right here. Compare these 2 relationships. The points, I'm going to only show 2 of these. Stronger relationships will be much wetter around the line. Look at only those 2. Closer, great job right there, Emma. So if you think about only these 2 relationships right here, the stronger one, and I'm just coming up with values of correlation for this by my estimates, the stronger one is going to be the one that the points are tighter around the line. So when you have a relationship right here that's super weak, it's going to be close to 0. Now, it might not be exactly 0. It could be a little negative. It could be a little positive. But the weakest relationships are going to be the ones that do not show any linear relationship going up or down. The line would be flat across. Now, this one right here is a bit of a weird one because it's still positive, but it's not as linear as this one. This one has a stronger linear relationship because the line goes through the data better. This one still has a relationship, but it's not as strong as this one. So this is our most strong positive, which means the value should be closest to what? So D, if we're looking through answers, is our most strong positive. Its value will be closest to what? D is most strong positive. Its value when we look through answers will be closest to what? Most strong positive. Its value will be closest to what? 1. This is the weakest. Its value, and the sign doesn't matter, will be closest to what? Great job, Garrett. So this is the weakest. Its value will be closest to what? 0. And it doesn't matter positive or negative. We're just going to look for closest to 0. Just whatever closest to 0 is the weakest. This is negative, so it has to be negative. And there's only there's 2 negatives, and it's strongest negative then. So this one is negative, and it's somewhat strong. And then this is the second strongest positive, so second one that's closest to 1. So does that make sense, Elizabeth, right there? Describing them with the strength, direction, form, unusual features. Understanding strength is closer to positive 1 or negative 1. Knowing that weakest is 0 will help solve these answers because when we find the weakest, it's closest to 0. When we find the most strong positive, it's closest to positive 1. When we find the most strong negative, it's closest to negative 1. And then this one right here can be deduced because it's the second strongest positive. So really, I like this question a lot because it goes over strength, direction, form. There's no outliers doing weird things though. Okay. Good questions. Huge shout out to everyone in the chat. We're just going crazy on the points. Assuming the relationship. Assuming the relationship. Oh, yeah. Katrina ones are good too. And huge thank you. Like, I can't say how many people are doing well in my class. I mean, I can say I posted on Discord like a screenshot of last semester to this semester. People are really taking advantage of these office hours. Several scatter plots. Graphic A, positive. Graphic B, weak negative. No, 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 not that weak. Graphic D, super weak negative. Graphic C, positive. Check answer. Good to go. I love those ones. They're just fun. Thank you so much, Reese, right there. Thank you, everybody. I just knocked that one out because it's like basically the same question that we've been doing. Assuming the relationship. Yeah, thank you, Emma. No, really, like, grades are like almost a whole letter grade higher. Like, it's pretty crazy. The fact that we're like a letter grade higher than we usually are. Did we already do assuming the relationship? Might find another one. We need another question right here. Oh, I mean, I'll pick one. Remember, choose the very start of the question because that's what I look for. So make sure to give the very, very start of the question. I don't see assuming the relationship yet. So drop another question in the chat. Roller coaster one gets me. Kentucky Derby, okay. The roller coaster one gets me all the time. There's just this weird thing about it where it's like it goes against what I think. So we should maybe do that one. I'll get it wrong. I'll give you some points. It's just weird. This one is a really good concept which applies to a lot of questions. The world happiness. Oh, we did that one earlier, Maggie. We could do it again, but it should be at the 20-minute mark. If you go back, you would need to go back 38 minutes in this video. If you rewind 38 minutes, you'll find it right there. Standardizing the variable means, that means turning them into z-scores. We can find that one too. That means turning them into z-scores, Reese, right there. And actually, this one's going to do this. So check out this question. Yeah. You're welcome, Maggie, and thank you for asking. I try to put as many questions in these videos as I can, but always ask. And if we run out of new questions, we go back because you're here. So you get to ask. This question, once again, is going to cover this idea for us about standardizing variables. And so we're going to see this in action with this question. MyPearson. Cut my finger and don't get to type with it. Okay. So this is about standardizing variables right here. And it's important to know what goes on with the formulas for finding correlation. To standardize means, in this instance, to turn to what's. Standardizing the variables, the formula we will use from the textbook, means we're going to take our x and take our y and turn them into what's. You take your x, you take your y's, you turn them into what's. And this will answer other questions if you're working on the assignment too, because it doesn't change anything when you do this. It's just how the formula works. Correlation is unitless, and we turn it into z-scores, which are also unitless. There are other ways to solve for correlation. You can see other formulas here. So think about this. We're already changing the units of the values, because if I were to look at the correlation between height and weight, would it measure how I measure height and would it matter how I measure height and weight? Like if I measure weight in stones or weight in kilograms or weight in pounds, would that change the correlation? Would that change the correlation? Would it be like more, would it make it like negative now? Like, oh my gosh, people who weigh more now are shorter. Reese, 100 points. The answer is no. Because correlation is unitless, the units you measure the values in don't matter.
It doesn't matter.
No, Reese, 100 points again. Don't worry. You get points here. That's what we love. Answer questions. You're doing it. So whatever you measure it in is going to be ripped away when you turn it into what's. Think about why the units don't matter theoretically. Whatever units you measure, if you do inches, miles, feet, centimeters, millimeters, gigameters, kilometers, you measure people in kilometers, like you are 0.001 kilometers tall. All of that's going to be taken away. All those units are going to be removed when you turn it into what's. That's why it doesn't matter what units we measure it in.
It doesn't matter.
All of those units you're using are going to be removed when you solve it, because you're going to turn the variables into what's. Why does it not matter? All those units you have the problem in. Well, because, so here's the thing, and hopefully just tell me if this doesn't make sense. You're going to convert them to z-scores, and z-scores are unitless. So however you measure it, I mean, because you can convert kilometers to meters, you can convert kilometers to inches. So you're just converting it to another unit. And z-scores are unitless because they're the same thing every time. Yeah, exactly. So that's why it doesn't matter. So we go here to the question, see what it says. If we were to change these things right here, change how we measure it, correct for an error, the sign of the correlation would not change. And the magnitude, which is how close it is to negative or positive 1, like magnitude just means strength, using another word for that, would not change. Because the z-scores upon which the correlation is based would not change. So once again, pretty easy question if you know what it's asking. It's saying, hey, if we change how we measure this, we're still measuring it. It's not going to change the reality of how these things are correlated. Like we have to correct the measurements. Well, you're just moving everything over. The z-scores stay the same. So since the z-scores stay the same, the z-scores are actually the way we calculate it. And other questions hit upon this idea too. Like there's a lot of them that basically do this. The correlation would not change because it's based on standardized values. Yeah. I don't even need to read the question. I can just read the answer. The correlation would not change because it's based on z-scores. The z-scores of the prediction errors are the same regardless of the units. Yeah, it's a really cool thing right there. So that question I just clicked on was like the exact same thing. It's literally just like correlations based on z-scores. So doesn't matter if you change things.
It doesn't
Not gonna
matter.
matter. All right, which one do we have next? Assuming the relationship. I couldn't find that one. Which one should we do next? That one's a quick one right there. Let me go do that one. If I see one that's really quick, I'll just do it. In a study of streams, what's the first thing you see with this data? Drop another question because we're out of questions. I'm picking questions now. What's the first thing you see with this data up here on the screen? Start talking to me about it while I write the notes. Don't even worry about their answers. Just start thinking about the conditions for correlation. Not linear. Savannah, you already figured it out. 100 points in the chat. I haven't even marked the question yet and we know the answer. Because correlation is meant for 2 quantitative variables, and this is 2 quantitative variables, so we can talk about it, but we measure the strength, direction, and linear forms. So this is a non-linear. The scatter plot is not linear, so we shouldn't be doing correlation. It's got a non-linear. If we were to put a line through it, the line would not go well through the data. It would have to bend. This is a non-linear form. I know, Savannah, Savannah right there. Keep it up. Really good practice. Just like you see something like that, you're like, what's wrong with doing correlation right here? And don't read their answers. See if you know it. Another right here, the National Insurance Crime Bureau. It's just a quick multiple choice. So let's get it done. I'm picking like these short ones here and just putting them in the video and then talking about the concepts. They are doing car and stolen. So think about your conditions. Don't even read their answers. Don't read their answers. They're doing car and stolen. So they are doing car and stolen. Don't read their answers. What's wrong with here with doing car and stolen? So I'll mark this question. Don't read their answers. They want to do correlation between car and stolen. Reese, you got it for 100 points. It's that you can't be doing the idea of correlation right here because both variables are not quantitative, and correlation is only meant to measure the strength and direction of 2 quantitative variables. We do have test questions that literally do this to you where it says like, can we do the correlation between this and this? And then you have to ask first, is it 2 quantitative variables? So we just need to look for something that says like, this is a bad idea because it's not 2 quantitative variables. And no, because the type of car a person owns is not quantitative. Yeah, there you go. And so there we go. That's it. You don't have 2 quantitative variables. You're not doing correlation. You're doing something. A study examined brain cells. Let's go check it out. Thank you, Savannah, right there. Study. I think this is a quick one too, right? I think it's got like a graphic, doesn't it? There's some tougher ones. Like not that, like we can do all, I'm just like, we're just going through questions. We're doing it. You see like that one's longer because it gives you data. We're doing a lot though. Antidepressants. Oh, the roller coaster one, that's the one I want to come back to. Oh, roller coaster one. Oh wait, is that another Kentucky Derby one? Maybe that's, oh here we go, Brain says, yep, it's a shorter one. This one I get mad about sometimes. I have gotten this one wrong. We have to be very careful with it. I'm pretty sure, maybe it's a different version I get wrong. Because I look at it and it's, so this one goes, well, talk to me about it while I put the note. What is the strength, direction, form, and does it have unusual features here? What is the strength, direction, and form? It's pretty weak. I agree. And when we talk about weak, we're talking about how scattered out are the points. And so if you notice right here, if we grab an image of it and we start drawing, I think it has a little bit. And this is where I could get it wrong, Savannah. So you're going to get some big points if I'm wrong. Because I have gotten this one wrong. I get mad at MyPearson and I'm like, oh. So you get to see the answer, which is good. I think it has some linear form to it. And I think I've said it's not linear at times because it has a little bit of a bend. But it's pretty weak. And it's got some linearity to it. So I'm going pretty weak. So pretty weak. Somewhat linear. It is positive. And there's no real big outliers. Does that make sense? So strength, somewhat weak. Direction, it goes up. And form, somewhat linear. So let's see which answers confirm on this and see if Brian gets it right this semester. Okay. It is definitely not strong, so B's eliminated. Moderately weak. I don't know if I'd go for that. Okay, wait, here we go. But it's definitely not negative. Okay, so now we're between these three. Very weak or possibly no association. That one's wrong because I think it has some association. And now we're between just two of the answers. Curved. That's where I get mad. At least one outlier. No. Okay, here we go. This is a moderately weak, positive, straight association between the two variables. And the answer is 0. Savannah, 200 points. Savannah got it. Points. Add, plus, viewers. We got to add in a special 200 points. Savannah was correct. They're calling this a no association. And then I get mad. I remember what I do now. Every semester I do this, I get mad and I go to core demo over here and I go to actual size. For my core demo, I got to run it. And then I go to view, actual size, and I start making the plot. And I'm like, it has some sort of, it's got something. Look at this. You do that little thing over there, that's going to cause some sort of thing. And I'm like, this would have some sort of moderate weak. There's my impersonation of the graphic. And you can see right here, that's my best little sketch of it. Savannah, does my little sketch of it look kind of like it? Yes or no? What do you say? Does my little sketch of that look kind of like it? So my sketch right over here, does it look kind of like this? Somewhat like it? Yes. What is the correlation? I do this every semester now. I remember this question. I know this question. What is the correlation on my graphic? What is the correlation on my graphic? It's up there, not the R squared, but the R. The correlation on my graphic is 0.36, which is moderate weak. And so MyPearson, come on, tell me the correlation of that because I'm estimating it to be moderate weak. So moderate is 0.5, weak is closer to 0.25. Those are not, you'll see different people disagreeing. They're like, weak is 0.2. Just a name we give it. The value of correlation closer to 0 is weaker. And the higher it is, the closer to -1 in absolute value is, the stronger it is. So once again, MyPearson tricking me again this semester, but you get to see the answer and you get points if you're right and Brian's wrong. So Savannah, great job right there with an extra 100 points. Excellent work, Savannah. They're calling this very weak or possibly no association. I wish they just gave the value of what. I wish they just told us the value of what for this. What letter do you think I wish they gave us for this? I wish for this, they just told us, and you should know this, that this is the metric we use to analyze it. I wish, you're welcome, Savannah. I wish they gave what value. Where'd that graphic go that we had with it? Hard time understanding the correlation as displayed over. Yeah, we can do it. Yeah, let's do it again. Several scatter plots. Here's a good one. Correlation is measured by R. And if they gave the value of R, we'd be good. So Reese, we got it. Those are some of my favorite ones. We were doing a bunch of them earlier, but I don't mind. Those are some of my, I mean, I don't mind doing any questions, but these are some of my favorites. And you'd be like, Brian, you're crazy. And I say, I know. I love these questions. When you get them down, so we're going to do the practice on how to do it again. We are doing a ridiculous amount of questions. The correlation, Mom, you're welcome. Have a great day, Elizabeth. Keep being an awesome mom. Shouts to the kids. Awesome. Check back later. We'll be doing more. Okay, I think it's right here is the ones. Okay. Okay, there we go. Okay, so when you do this right here, what we have to do is we have to talk about the 4 ways to describe correlation. So Reese, what are the 4 ways to describe, hints on the screen? What are the 4 ways to describe correlation? See if you can remember the 4 ways to describe it, not the conditions, but the 4 ways to describe correlation. What are the 4 metrics or 4 characteristics, not shape, center, spread, that's univariate, but what are the 4 metrics we use to describe correlation? What are they called? The 4 metrics to describe correlation are what? The 4 descriptors for correlation will be what? What will they be? 3 conditions are QQ straight enough, no outliers. But what are the 4 kind of qualities of correlation that we analyze? What do we do? If you know it, if you're in the chat or following along later, see if you can write down the 4 ways we describe correlation. These are the things to like know and understand and be able to explain to people. Be like, oh yeah, correlation measures this. What do we analyze? Very close. Good answers, Reese. So you are on the right track. Answer is 100 points right there. Strength is 1. Direction is another. Form is another. Unusual features is the last. So this is what we analyze with correlation: is strength, direction, form, unusual features. So you're really on the right track right there. Strength is going to be how tight the points are around the form. So you know what? Let's do form first right here. Form is either going, really? I got the blue pen selected. Form is either going to be a line or not a line. So notice how this is linear, 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 and not linear. So linear, 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 not linear. To be able to analyze the form, try drawing through the middle of the data. Like if all the points were to converge in on something, try drawing through that. So is it linear or not linear? Those are really only the 2 forms right there. Next, we look at the strength. Strength is tightness in vertical scatter around the form. What do I mean by vertical scatter? If you start tracing up or down, the strength is going to be how tight it is around the form. Look at how we're going around the form and just tracing up or down. What are the 2 strongest relationships in this data right now? What are the 2 strongest relationships in this data? Graphic what and what are the 2 strongest relationships? It's the tightness around the form. What is the 2 strongest? What are the 2 strongest? Which graphics are the 2 strongest? I'm going to add 5 and 6 on here too. What are the 2 strongest? One and 4, that is correct. I'm adding graphic 5 and 6, so I'll basically cover almost everything you could get on the quiz by doing 5 down here and 6. So if we go back and add the form to this, this is nonlinear, and this is not, it's linear, it's not really nonlinear, it's just weak, it's non-existent. More on that in a moment. So this is nonlinear, and this is linear, but very, very weak. And you can see right here, this is strong also. So this is strong, this is strong, this is strong, this is moderate, and this is weak. This, now we go to the direction, and the direction right here is negative, positive. This is neither, and this is going to be neither also, and this is positive, and this is positive. Does that make sense, Reese, right here? So try going through marking these graphics, try understanding, are they a linear form or not a linear form? Are they weak? Are they moderate? Are they strong? Know that strength is the vertical scatter around the proper form. It's not just linear strength, which is only measured by correlation, because both of these right here, this has correlation equal to 0, and this has correlation equal to 0. Graphic 6 has no relationship. Graphic 6 is a no association, where graphic 5 is a nonlinear kind of parabolic association. So these are some of the trick ones you get where it's like no association would only be graphic 6. Graphic 5 shows a nonlinear association. Does that make sense? Because correlation only measures linear strength, so correlation can be 0 right there. How are we doing, Reese? Because this hopefully should answer all of them. by going through and marking strength, direction, form. There's no unusual features, which would just be like outliers. Like if you had, like if you want to do an unusual feature, just add in an outlier, and that's going to be an unusual feature, which that doesn't have. So great job, Maggie, right there. So now we go back, look at the question. Oh, well, we already did it. None of these scatter plots show no association. All right, here, I'll undo it. Here we go. Which of them show no? Did I keep my answers? Oh, which of them show no association? None of them show no association. Or is it, did I keep my answers? Oh, kept my answers. Oh, that's nice of it. Yeah, we basically answered all of them. Does that make more sense, Reese? And check out, we've done this a few times, but if you walk through and try to make sure you have each one described properly, there are some weird ones where it's like moderate or things like that, but I do like these questions a lot. They're Brian approved questions. What else do we have? Done a lot. The Office of Federal Housing. The Office of Federal. Someone asked for this recently too. How's everyone doing today? Some music here. Okay, let's check it out. The Office of Federal Housing Enterprise Oversight collects data on various aspects of housing costs around the United States. Here's a scatter plot of what we see, and the correlation is 0.64. That is a moderately strong correlation. Strong is closer to 0.75. Perfect is closer to 1. These are just descriptors I use. Other people have different metrics, but the stronger it is, the closer it is to 1 or -1. The weaker it is, closer to 0. And if you notice right here, little bit of weirdness, not big outliers. You got an outlier up here, maybe. I clicked a second song, that's what I did. I wonder. You got an outlier up here, weirdness down here, not big outliers, because the other data is kind of outliering too. One way to see if you have outliers is to do what's called a density ellipse. And so you take your data, you start doing concentric circles out from the center of it. You find the center, and then you start going concentric circles out. And there you go. You can see like this point up here has about the same outlier nature of these because it's on like the ring. And so yeah, those are your big outliers, maybe. If we were to put the line through the data. Something, I can't draw a line today. So moderate outliers, nothing too crazy. It's pretty decent relationship. Nothing too crazy. There's metrics we can get with stats to quantify those outliers. Describe the relationship. It's a moderate positive if both variables were standardized. And this one right here is a classic question because standardizing does nothing to the values because they're based on z-scores. You're already standardizing them to begin with, so what would happen to the correlation? Well, if you're standardizing them and standardizing already does nothing, nothing would happen. If we were to measure this differently, how would it change correlation? Well, we're already standardizing them, so it would have the same sign. The magnitude would not change because no matter what we do to it, it doesn't change it. Now we get to a weird point, an outlierish point. Suppose DC has a value of 548 and 45,000. Let's go to the data. 548 is going to be about here. We'll change the color. 548 is about here, and 45,000 maybe here. Yeah, that's it right there. It's an interesting spot they chose. So what that's going to do, our outliers can do anything. I wish they put it further high. Let me see if I got the values right. 548. That's 600. Yeah, that's about where it's at. So we're talking about a point here. Really? Oh, I got the eraser on. There's the point. So they're adding this point to the data, and the line already goes like this right here. So if you think about like a balancing point on this towards the center of it, this is going to pull the line up towards it. So once again, we see outliers can do anything. The outlier is going to pull it up towards it. So it's going to it's going to decrease the slope and make the correlation weaker. Points closer to the center of this would make it stronger. Points further out make it weaker. So that's going to make it weaker. and bring the correlation closer to 0 because it is farther away from the model. It's more of an outlier to the rest of the relationship. So the correlation coefficient, it'd probably have the same sign. It's just going to get weaker. The magnitude would decrease. Canvas content, yeah, let's do the next. So that should be, is there one more? These data points provide proof. No, we don't do proof. They do not provide proof since the correlation value cannot prove any causation. We just don't do that. So really good question right there. That the tricky one is going to be the outlier right there. And hopefully I've drawn it well enough that you can see that the red line is what it originally was. And if you think about like a teeter-totter, points pull the teeter-totter towards them. So outliers can do anything. The magnitude is getting smaller because it's getting closer to 0. Magnitude is just a proxy for strength, another way to say strength. And the sign probably wouldn't change. Now, if you put the point, if you take the point and go all the way up here, it could be enough at that point, and we'll do canvas content next. At this point, you could have enough to change the sign of it. So because outliers can do anything, you could have enough to make it go negative. So it's possible. Just remember that the outliers can do anything to correlation, positive, negative sign. It's some of the easiest questions on the test, like outliers can do this correlation. The answer is always good. Yeah. I'm gonna see my answer. Okay, let's go do canvas content. Oh, I'll go this song. Okay. Canvas content. What's up? Canvas content. Great work, Savannah. Should be near complete for the test. Oh, canvas content due a little while later, but we got it. I love doing canvas content. Preview. Okay, remember, the best way we can do canvas content is to know the answers before looking at the questions. So let's go look at it. Here we go. Okay. Which of the following is not a way to describe bivariate quantitative data? Now, don't look at the answers. What are the ways to describe bivariate quantitative data? We've been talking about this a lot today. Put it on a note card. The ways to describe bivariate quantitative data are. What are the ways to describe? Don't look at the answers. Remember the 4 ways to describe bivariate quantitative data. I'll give a quick hint on the screen, but what are the 4 ways to describe bivariate quantitative data? What are the 4 ways to describe bivariate quantitative data? Once again, good stuff because we're like, oh, what are the 4 ways to talk about it? So like if you get a scatter plot, when you get a scatter plot, there's 4 things you should be able to talk about. Don't look at the answers. I didn't know the answers without looking at them, and then you really know the content. You know the canvas content. So the answer would be strength, which is the tightness around the vertical scatter, or the vertical scatter around the form. Direction, positive, negative, or neither. The direction, do we just do direction? Form, linear, nonlinear, or unusual features. So one of them is put in here. The shape is for univariate. Shape center spread is univariate quantitative. Shape center spread is univariate quantitative. Which of the following is a bivariate display of quantitative data? Write down this graphic if you don't have it. Look at your graphic, try to answer it. Look at the screen. Bivariate quantitative data, there's 2 answers to bivariate quantitative. The way to use this information on the screen, so see if you can answer it in the chat, maybe get points in the chat, is to say, what is my y variable? And if you don't have an x, you'd be up here in the univariate displays. This is univariate quantitative, univariate categorical. We don't do logistic in this class, hence it's crossed out. Logistic would be a categorical y and a quantitative x variable. And then down here, you've got bivariate categorical. Notice the color coding, green and green. Univariate quantitative, univariate categorical, bivariate categorical. Then here's your bivariate quantitative. Time plots are special case scatter plots where time's on the x-axis, like milk price over time of year, because time of year is a quantitative x vector. And then the price is quantitative y. And scatter plots are just 2 quantitative variables. So time plots are special scatter plots. And then histograms and all these up here are going to be univariate quantitative. Notice the blue. The black ones are going to be just a combo of categorical quantitative, such as side-by-side box plots are when you break up the box plots into categories. So once again, write this down if you don't have it, because if you've been practicing with this, bivariate quantitative is going to be scatterplot right there. A strong relationship can have correlation equal to 0. There's a graphic we should think about every single time we hear this. There's many, many ways this can happen. And graphic number what is a strong correlation, a strong association. Let's see, for 100 points, does anyone know? Graphic what is a strong association with correlation of 0? What graphic on this screen has a strong association with correlation of 0? What graphic on this screen has a strong association? What graphic has a strong association with correlation 0? Does anyone know? Leave it here for a moment. What graphic on this screen has a strong association with correlation of 0? What graphic on this screen has a strong, is it 1, 2, 3, 4, 5, or 6? What graphic on this screen has a strong correlation? Strong association. Oh my gosh, I'm going to say it wrong. Strong association with correlation of 0. Good guess, Amy, 100 points. Graphic 6 is weak, no association. So graphic 6 does not have any association. Graphic 5 has a correlation of 0, but is strong, and it doesn't have correlation because it's not linear. Both of these have no correlation down here. 5 and 6 had no correlation, but 6 has no association because there's no form to it. It's just random. Where 5 has an association, its association is just not linear. It has a parabolic form to it. So there's some association in the data, it's just not linear. So we see here that yes, there can be associations with a correlation of 0. So that is true. A strong relationship can have a correlation close to 0 if it follows a nonlinear form. To create a scatterplot, both variables must be what? What's our first condition for correlation, which means you're making scatterplots to analyze it. To create a scatterplot, both variables must be what? You can say the condition in the chat, but once again, this is practice, and then you have to know why you're saying it. So you have to be like, oh, the condition is something, something. What is the first condition to do correlation? So memorize the conditions. We say them in our class of QQ, straight enough, no outliers. Well, that means to create a scatterplot, QQ, both variables must be quantitative. So to create a scatterplot, that's why we say QQ. It's like quantitative data. And you can also see it over here. Great job, quantitative variables. You got it, Mag. We'll throw some points in a second. Notice how this is the quantitative region, and you get scatterplots. And that's the condition to do correlation, which is analyzed via scatterplots. 100 points, Maggie, right there. So good practice, especially on these. Next one, a p-value for correlation, which is statistically significant, implies the correlation is due to random chance. Probably one of the toughest ones on here, and I could spend the rest of office hours right now talking about p-values. Here's the key things to know about p-values when we're doing them. Write down here p-value facts. P-value facts. Facts? Okay. 1. A p-value below 0.05 is statistically significant. Statistically significant means we reject the null. The null for the correlation test is that there is no correlation. Each test has a different null. Can't state that enough. It's not always the same null you're talking about. Last but not least, statistically, or when we reject the null, we are saying, oh my gosh. What we saw is like a random key, is unlikely by random chance. P less than 0.05. Unlikely. This is a low probability. So it's unlikely what we saw was by random chance. Okay. Some facts right here which can often help. We go into more detail, and I don't want you to memorize them for now. I'll do that, but we need to go into detail on what these mean. Because if we have correlation, we are going to be analyzing the relationship between two quantitative variables, and what you might expect if there's no correlation, which is what a null means. The null is a starting hypothesis. You might expect to see a relationship that looks like this. So this would have a correlation value close to 0. And if there is no correlation, that means the p-value associated would be close to 1, because this is a likely thing to see if there's no correlation. Like, if there is no correlation, I expect to see no correlation. This is an expected result. Like, what I saw here was expected given there's no correlation. So now we go and look at this graphic, which has a correlation closer to like 1. And so with this, that has a correlation closer to 1, this is very unlikely to see if there is no correlation. And by unlikely, we mean improbable. So the p-value measures the likelihood of what we see in our data, given the null is true. So the p-value, as a probability, says what you're noticing right here is very unlikely, low probability, given the null is true, due to randomness. This one over here is actually the one on the far side. It's actually the most likely thing to see, which is a correlation of 0. If there is no correlation, you would expect to see this, so high probability. So we look at what we are asked, and it says a p-value for correlation, which is statistically significant, less than 0.05, low probability, implies that correlation is due to random chance. No, it implies it's unlikely due to random chance, so this is false. Very good question, very in-depth, and it's kind of a guess for a lot of people, but that's a really good question. I got it right, 10 out of 10. Do one more version of this right here. Which of the following is not a way to describe bivariate data? We already did this one. It's going to be shape, because shape center spread is for univariate, where strength, direction, form, unusual features is for bivariate, so shape is wrong. Outliers, oh, please help me right here. If you read this, outliers can do something to correlation. Just outliers can do blank to correlation. Let's make a fake test question right here. Are you ready? Outliers can do blank to correlation. So true or false? You should know this if you're watching this right now. Outliers can do this to correlation. Anything we say here, what? Outliers can do this to correlation. What would you say? Outliers can do this to correlation. Anything that's said here, whatever it says, outliers can do this to correlation, the answer is true. That's only to correlation, though. Be careful. It doesn't change the median, doesn't change the IQR. But when you hear outliers can do this, and good answers, well, no. So outliers can do, if you have things like outliers can make a weak correlation strong, outliers can make a strong correlation weak. And Savannah, good answers right there. Outliers, whatever we say, outliers can do this to correlation. The answer is true. Because what you can have right here, take a look, is you can have correlation. Here, we'll end this and we'll redo it. Tell me the value of correlation on the screen right now. Tell me the value of correlation. You have to look up here. You have to look at this little tiny number. What is the value of correlation? What is the value of correlation? What is the value of correlation on the screen? You have to look right there on the screen and tell me the value of R. R is the value of sample correlation. What is it? It's 1. Do you think an outlier can make this correlation 0? Do you think one outlier could make this correlation 0? Yes or no? Do you think one outlier could make this correlation 0? Wow. Do you think one outlier could make that correlation 0?
Wow.
The answer is yes. 100 points right there. One outlier has made the correlation 0. So one outlier changed the correlation value from 1 to 0. And I got so lucky where I put that. Check out here. What is the correlation when we see a scatter of dots that looks like a circle? A scatter of dots that looks like a circle probably has a value of correlation closer to what? A scatter of dots that look like a circle probably has a value of correlation closer to what? A scatter of dots that look like a circle probably has a value of correlation closer to what? A scatter of dots that look like a circle probably has a value of correlation that looks like a what? Closer to 0. Great job, Savannah. So could one outlier make this a strong correlation? Do you think one outlier could make this a strong positive correlation? Do you think one outlier over here in the corner could make it a strong positive correlation? Do you think one outlier could make it a weak or negative correlation? Because what can outliers do? What's the deal with outliers when it comes to outliers and correlation? Anything is possible. So you have one outlier can drastically impact it. So that's why we say QQ straight enough, no outliers, because they totally impact everything. They control everything. We don't want those outliers. So can outliers make a weak correlation strong? Yeah, sure. Whatever you say. If you say outliers and correlation together and they can do something, the answer is true. Don't get it wrong on the test. A strong relationship can have a correlation equal to 0. Very true, because it can be nonlinear. Which of the following analyzes bivariate quantitative, scatterplot? And here we go. I love these questions because you need to know exactly what we're looking for. This one says, what is the weakest correlation in the matrix? Enter the value. So what should you look for? Don't worry about the answer. If you hear weakest correlation, your brain says, find the what? If you hear weakest correlation, your brain says, I need to find the value in this matrix, what? If you hear weakest, your brain says, I need to find the value that's what? You see weakest correlation, find the weakest correlation. You say, I have to find the value what? Whatever value is inside of here, I need to find the one that is what to what. How would you answer, look at this right here and be like, oh, weakest? Kind of. Go into more detail, Savannah. Points right there. Go into more detail. What do you mean by smallest? You're kind of right, maybe. Yeah, you points right there. Go into more detail. Weakest correlation means closest to what? This is kind of right. You might have even good work, but weakest, we should say, I need to find the one that is mathematically closest to what? 0. Great job, Amy, right there. Yep. So what would it be? Tell me the weakest correlation. We have to find the one closest to 0. Yep. That's weakest. Sign doesn't matter when it comes to strength. It's closest to 0. So what is the weakest correlation in this matrix? When it says find the weakest correlation, the answer is find the one closest to 0. So which one of these would that be? Would it be? Points for answers. Take a guess. Great job, Savannah. You got it. Yep. Savannah got it. Closest to 0 looks to be this, unless I'm misreading it. Double check your numbers. Oh, wait a minute, Savannah. Uh-oh. Savannah, we're throwing you 100 points. Uh-oh. Problem. More points if you can find it. Careful. Remember what? No, Savannah, you got another 100 points. Keep it up. You get points for answering. There's just points for answering. You got it. You got it. Don't worry about it. Good work, Savannah. That is right now. Point. There we go. Should be good. Really good quiz, because we made it. Very good test prep. Don't worry, Savannah, I'm being honest. I actually thought it was negative 0.062, and I didn't see the 0.011. You know what's really cool is if we do this in statistical software right here, we have ways of finding it very quickly. I've got a function over here called all correlations, and all correlations literally gets you all the correlations in the data set. So here's all 136 correlations, every single correlation. And I can go here to sorted equals magnitude, and I can go to the first correlation, and oh, that's the first row. So I mean, first row. There's the strongest, and 136 is the weakest. There we go. And there's the strongest, and there's the weakest. So the weakest correlation is number of tattoos in video games, not statistically significant. P-value is very high. And then the strongest correlation is between weight and desired weight with a correlation of 0.87, super ridiculously statistically significant with a p-value of 0.00098, like 217 zeros. So you can find this out very quickly. And the thing is, if you did a core matrix, the correlation matrix is just ridiculous to look at. Correlation matrices are good for smaller data sets, but for larger data sets, they're just a mess. So I don't know of anyone who would go and like look through this big correlation matrix. Like you might even be able to get it to display on the screen here. There it is. There's the correlation matrix between all of them, 136 correlations. or you could just do all correlations, and then you can do the list of it, and I can get every correlation here sorted from weakest to strongest. And so much easier to look at this with variable 1, variable 2 correlations, and then p-value for statistical significance. 0.05 is going to be, oh, wait, no, that's 0.9. So here's where statistical significance starts. So I could go right here and say rows 1 through 68. Oh, I didn't do the thing. And now I have all statistically significant correlations, and I can call it all C for all correlations, and I can go over here and look at it like an Excel spreadsheet, and that's all the statistically significant correlations. I can even sort it to see the ones with desired weights, but every one of these is unlikely by random chance. I love stats. So that's literally every single statistically significant correlation, and I can even sort it by negative to positive really quickly here, just clicking the columns. Once again, now it's a point-click software. Just a quick question for the Stat 201. There are some test prep questions for test 1 going on campus, but we could figure out a way to have open to all the online. Yeah, Space Kate, good to see you there, Space Cat. I think Terry sent out some. Let's take a look at those. Yeah, let me go grab those. Terry sent out some right here. And also we have the Stat 201 prep, and these should be posted. I'll tell Terry, why don't we post these? Thank you, Space Kate right there. Cat, I see you can Kate and Cat. Where is that test prep? Terry sent it out. Review questions, here we go. I'm gonna display it on the screen right here, and I'll talk to Terry about getting this out to students. But good question. I saved this, right? Oh, I saved that. Okay, now it's saved. All right, let me save this. Okay. So here is what Terry wrote. Enable editing, 2 seconds right here. Yes, it's got a lot of stuff. We can maybe do this in class coming up. Be a good review. So maybe I'll spend next class going through this. But this is the thing right here. I'll go page by page. So in case someone wants to screenshot it or pause the screens, they can. And let me label this. And I'll tell Terry we need to get this posted for people to do. Is this what you're talking about, Space Cat? Is this what you're mentioning right here? Let me know if this is what you're talking about. Or there's more. There's things I don't know about. So test 1 extra review. Okay, so here we are. And can I go page view? Page view. Sure. Here's the first page of it. First and second page. Here's the third and fourth page. Here's the next page. Here's the next page. Here's the last page. So I'm gonna do a full page on it. Oh, it's a very good review. And y'all, let me see. For the answers too, but we'll try to work through it, and I'll tell Terry this needs to get posted. Let's do the normal curve one. A lot of people get stuck on normal curve. Okay, so here's the normal curve question, and it says to us, and this is very similar to what we have posted already on the review page. You'll notice right there, I'm going to pin MuBot's message. So here is the pinned message from MuBot, and this is a very similar question what's on the review page. Now, what I suggest doing as soon as you get one of these questions right here is to draw your normal curve. You want to have on a sheet of paper a normal curve drawn out. So when you start the test or you get to a question that uses the normal curve, start drawing the normal curve and put the z-scores on the bottom. And believe me, this is the best tip I can give you, is to draw the normal curve, try doing it before the test, and then have this normal curve picture. And then when it says something like the data is normally distributed, we'll do a normally distributed, that's the shape, with a mean of 98.2 and a standard deviation of 0.7. You go down here to the bottom and you put 98.2, and then you go up to 98.9 and 99.6 and 100.3. Then you go down to 97.5, 96.8, and then 96.1. And when you're done with the question, you simply erase the context on your curve because you can use it again. So you're going to use this curve. You don't get this with the test. You can't bring it to the test. But when you're doing the questions, I would have the numbers written out. So let's go look at the question using this method of solving it right here. And we'll go with side-by-side screen with this on the screen. 2 seconds. Let's get them side by side here. And here we go, side-by-side screen viewing it. You can see the question, and though I have my sheet of paper next to me right here to the side. Okay, so the question states, what percent of people had a body temperature lower than 97.14? What we can do is we can go right here and go to 97.14 and see that it's about here, and we would trace to the left and draw like this. Now, if you use the empirical rule on this question, you'd get that this is somewhere between, and we're not asked to use the empirical rule here, but if 95 is here in the center, then this would be more than 2.5 because that's what's below this region. Now, once again, we're not asked to use the empirical rule, but I've got a guesstimate of the answer, which is very good for solving these, and I've got a little drawing. Going up here, we see we're between -1 and -2, and I think they started out already with a hard question. Oh, wait a minute, 97.14, isn't that our number? Look at this right here, 97.14. So what this graphic right here has is the mark on the curve right here, and that is going to be, let's pull up the marker. This is our region. That is the same region we just drew. And so this is the area, but we want half of it. So we have to take this and divide. Really? That was very weird, computer. We have to take this area right here and divide it in half. Computer is possessed. We have to take that area and divide it in half because it's only half of this right here. So we take the point 13. Yeah, awesome. Yeah, Kate, did you get this right here? Thank you, Kate, and please swing by anytime. Go to this pinned link, and you can always email me at bstevens@utk.edu, and I can send you more information. You're always free to come here and ask questions. Thank you, Space Cat, right there. We love space cats. We love Earth cats too, space cats, all cats. Now we get a z-score of 1.286, and I kind of got a good guesstimate of that because I kind of know that z-score. 1.286 is going to be about here-ish. And we trace to the right, and we've got our little drawing to help us out. And this first one was an answer of 0.065 as the pen changes colors. Reason it was half of 13, check out the previous answer up here where we took half of 13 from this one right there. And it doesn't like when I draw in that region. That is not where 1.28 would be. It's too far over. That's not where 1.28 would be. So let's go up to this one. Now notice here, it doesn't use z-scores, but if we had put the numbers below here, we could see that maybe this is the z-score of 1.286. And it gives us the area below here, which is 90.07. And so the area below that is 90.07. So the area above this, we subtract from 100 and get 0.99. My gosh. Both these numbers should add up to 100 right here. Gotta run. Yeah. I think we have. We've done a lot of the quiz today. And so remember, we're just trying to find this area right here, which is the other side of the 90.07. So if you enter it as a decimal or whatever, you just do 0.997, take that, 1 minus it. We go 1 minus it, subtract from 1, and we get the remaining on the other side of it. So that would be 0.0993. Next one says between two temperatures. So 98.2 and 99. Ooh, this is an interesting one. I like this one. So we'd go right here, and we go to 98.2, which is here, the center of the curve, and 99.26. 99.26 is about over here. So if you look at this area that we're looking for, it's that right there. And I think each of these uses a different graphic. And if you look right here, I've kind of drawn this, so you can kind of guesstimate. And I think this is a good tricky one. The 99.26. So I'm thinking 99.26 is right here. I think this is where 99.26 is. But we only have the z-scores for it. We only have the z-scores. So I need to turn 99.26 into a z-score. Observation minus mean over standard deviation. And I meant too many zeros. And it's very close to that. I wish we had more decimal place accuracy. Did I do an error? 90. Oh, wait a minute. 99.26. Okay, wait. These answers, okay. No. Because 99.26 is not there. It's right here. Because that's where 99.26 is, and I can't circle it. But that's where 99.26 is. And we now know, and this is a lot easier question than I thought. Well, it's still a little tricky. We are looking for this area in here. And here's what we know. Below here is 50%. We're not looking for that. That's below the middle. And above here, like the previous question we did, is 0.065, because that's half of 13. If you take 13 and divide it in half, you get the area on both sides right here. So this area from here over is 50%. And then we need to subtract off this remaining area right there. I selected that pen. My computer doesn't like me. We need to subtract off this area. So it's 50% minus 0.065. So we go down here. That is a tricky one. That's harder than most of the questions we write these days. So it's 0.435. The drawing is a big help because we know what we're looking for. The 20th percentile is over on the left side of the curve. So when we go to the 20th percentile, it's going to be over here. Somewhere about there's the 20th percentile, the bottom 20%. Actually, no, I'm wrong, because this is the bottom 16% via the empirical rule, because 68% is inside, so 16 in either tail. So since we know where the bottom 16% is, and we know the 50% is the middle, we know the bottom 20% has to be a little bit above a z-score of -1. So we would go right here about and say this is about where the bottom 20% is, because this is a little bit further to the right than the bottom 16%. So that's about where we're looking for. And we scroll up, and there we go. We literally see a graphic right there. Now notice it's giving us the z-score. And if we go further in depth on this question, it tells us the middle 60% is here, meaning that there's 20% in either tail, confirming to us that this is going to be the bottom 20%, or the 20th percentile, the lowest 20%. So that's exactly where we drew over on our left with our picture. So this is a really good question right here. Now, what do we do with the z-score? The z-score is how many standard deviations above or below the mean something is. You can see the answer should be about 97.6 or 97.7, but we take the z-score right here, and the formula I'll write it down so you can see it, is the mean plus the z-score times the standard deviation is the observation. This is a reworking of the formula observation minus mean over standard deviation equals z-score. It's just been reformulated to solve for y instead of solving for the z-score. And so we're just going to plug in the numbers right here. We know what the mean is. It's 98.2. We're going to times 0.7 times the negative 0.842, which makes it negative. We take 98.2 and subtract that because it's negative and get 97.6. And look at about where we thought it would be. If you look over here on the curve, does that look to be where 97.6 would be if you were to look down there? I would say so, and you can even cheat over here if you drew your graphic right there. So 97.6 is the answer for the z-score, or the answer for where the 20th percentile would be at, 97.6. Really good questions right here, like really good in-depth questions. And the really big help to this is having a sheet of paper beside you and drawing out each question to be like, okay, which graphic should I be using? What does it look like I'm going for? And if you notice, we then drew it over here on the curve, but we had our own little drawing. I cannot state this enough that you want to be able to draw this out. If you try to do it all on your own, you're like, whatever, I'll just look at the graphics. Then you get confused. You're like, which graphic am I using? But we were able to deduce a lot of the answers and go to a graphic pretty quickly by saying, okay, so we're looking for something that has a line between 0 and 1, or 0 and -1, and we found it pretty quickly. There's some trickier ones we could ask, but these are really great. Well, let's head out. Great office hours. Let me hit save on this, make sure it's saved. Until then, bye for now, everyone. Bye! 5 hours. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.
Bye.